Okay, so in this video we are going to see how we process map information. We have a format in the mapping world called geoJSON, and and we had a need to process them in order to extract some information, to simplify them, and many other things that you can do with a map data. So for now we're going to let me just show you the map that we got from our provider. From our provider. So these are GeoJSON files for all the states in Mexico, right? Let's see state number 14, which is Jalisco. This is where I'm living at the moment, and let's just draw that GeoJSON with Google Map. Okay, first of all, this is a big file, so for a web application it's not usable. You need to simplify it, or maybe break it down to the municipality level, depends on the zoom level, and so there are so many things that you need to do in order to make a nice experience with map, right? Okay, what we have here, this is the entire state of Jalisco. And you see it's very dense. It looks very dense because it's broken down to they call it section electoral, like the district for voting. It's not even a municipality, so that's what it. So it's quite down there in the hierarchy. So first of all, for some cases we don't need that. We just need to draw the state border. How do we get the state border out of this data? First, you can try Googling. So you can avoid work maybe. So yeah, I did that. First, I came across these two pages. I couldn't find it anywhere else, not even in the some official government websites. So I got it in this GitHub from Diego Valle and this guy named Ponente in Causa. So let's see what we have here. The first one, Ponentes in Causa. Okay, we got this is a GeoJSON. This is a GeoJSON. Yeah, it's a GeoJSON. And it has a breakdown to state level. Okay, probably you would say, okay, this I'll take this. Fine, this can work, but the only thing is it's been heavily simplified. Yeah, there's a tool to reduce the size of a GeoJSON, so that's why you see these sharp edges. So it's not accurate anymore, and yeah, for some maybe you need another you have a different requirement, maybe a better precision, so you can use this, at least in my case. Now let's see what we have here in Diego Valle. We got a breakdown to the municipality level. Okay, fine, and you need a little work to get the state border, but the same, it's also has been simplified. You see these sharp edges. Okay, so I need to work based on the data that I have here. Let me see, where is it? Yeah, 23 megabytes of JSON file view. Yeah, this is the JSON, lots of points here. Okay, what is the easiest way to get this done? So I googled around and I came across this library, JavaScript library called turf, and somebody told us maybe you can try convex hull, but this is not really the solution, because you see, if you use convex hull, you will get a curve, or sorry, a polygon that would look, sorry, I can't draw on my screen, I don't have the tool here. Probably you'll get something like this, like almost like a circle. You don't get this part that goes like a bay here, you know. So I can use that. I've also I thought maybe we can, you know, unify these little polygons, unify them into one. Yeah, I tried that as well. And turf happens to have a function called union. And it is extremely slow. Yeah, because it has to work with lots and lots of points for this level of detail in the data that I have. So yeah, it's not practical. So then I came across these three things. The topo.json. Topo.json is a format. It's a very space efficient format for map, because instead of storing individual points, it extracts like a common paths between, you know, adjacent objects or polygons, and then so you got like, I can see like 6 times of size reduction when you make a topo.json out of GeoJSON. So yeah, so then I decided to start to work with this format. The first thing is you have to convert these GeoJSONs to topo.json. So you can use this one. Okay, this one. This tools, geotopo, is available in this package, topo.json server. So you need to do npm install, say, in your project, npm install topo.json, and you'll get the binary inside this directory. You just pass the output, the name of the output file, and then the input file, the GeoJSON, and the resulting they call it geometries will be assigned to an object called sectiones inside the topo.json. So let's just run the script. So at this moment I don't have the topo.json file, so it's empty. So let's run it. Bulk to topo, boom. I don't remember how long did it take. Probably not too long. Okay, yeah, we are halfway to the end. 25, 20, yeah, we're almost done. I think we're done. Oh, cool. So we got topo.json. So let's have a look inside the topo.json. also from the state of Jalisco. Yeah, so it's assigned to object name sections, and the geometries are this, and they speak in the terms of arcs. These arcs like the thing that they share between polygon that are next to each other. So let's see the size. The topo.json of Jalisco is 12 megabytes, and the geoJSON of Jalisco is 23. Okay, maybe I exaggerate like 6 times, but maybe it depends also on the shape, right? So it's really depends in compression. So we got the topo.json, so we can start working with that file instead of geoJSON. So what functions can we use to achieve our goal? So there's another package named topo.json client. It's also JavaScript thing. You just have to npm install, and there's a function called merge. So it's pretty similar to turf. I mean, the objective is the same, but the performance is, yeah, it's way significantly better. So yeah, this is the base of my solution, but there's some details then that makes my final code a little bit more. It took me more time than I thought. I thought it was just, let's just call the merge function and we're done. Nope. Because how do I explain that? The complexity, you know, how do I explain that? Why do I have to do more work than calling merge? This is strange because let me just let's just run the script first, and then I'll explain. I have the script. This one. We'll process all the topo.json file and pass it to my JavaScript code for each one of those files. Estado border topo.json. Boom. Okay, it takes around 2 minutes, and in the meantime we can see the the borders that it created. Okay, we are halfway. As far as Jalisco is concerned, we already got this one. Let me draw topo.json online. This one, topo.json's borders, section 14. Where's it? Processing system. Oh, this one. Import. Neat. Okay, wait. This is Jalisco, right? Yeah. It's quite nice actually. There's no inner lines. Give me a second. Yeah, there's some imperfection here. Like, I do not expect to see these lines. A little more work would be needed, but for now it's okay. What else? Okay, let's go back to my explanation. We got a topo.json. Let's compare that with the topo.json before the merge. This one is before the merge, right? So the code of my JavaScript code is like this. It reads the unmerged topo.json and do stuff here. Yeah, you can see I call the merge function and do other stuff below. Let's draw the unmerged version. 14. Import. See. Wow, Guadalajara is very dense. It has lots and lots of district for voting. I found that for some reason, for example, just to illustrate, it's not exactly this one. There, I think maybe one of these, but around here, without my further processing, other than the merge function, this area is considered as a separate area from the from the enclosing area, which is the state. So we got two polygons here, and they are drawn like this one is drawn superimposed to the state state map, right? And we don't want that. We want this to be at least either merge, but we did that. We did the merge, and it didn't work like 100%. So what I had to do was basically remove this one from my final result, right? So that's basically the idea for that additional processing. So yeah, we got the state border as a topo JSON. As a topo JSON, and but then some system they don't work with topo JSON. They still work with the GeoJSON, so we need to convert it back to GeoJSON. So I have the script for that. Bulk topo to geo. Yeah, it just reads the border, the topo JSON border, and use this. The topo to geo is available in the topo JSON client modules. Alright, bulk topo to geo. Bam. What is this? No such file. JSON border topo to geo. Why? GeoJSON borders. Huh? JSON. Oh, we got the borders. We got the topo JSON. What is missing here? Oh yeah, I forgot to add a line in the script to create the directory for the output. Okay, go JSON borders. Yep, now it should work. Yep. Okay, now we got the GeoJSON for the borders there. Let's just draw it on the map again in Google Map. Jalisco. Okay. Yeah, you can still see those lines. Now let's try drawing this Baja California Sur, which is section 3. There's a lookup table for that actually. Here. So each state has its code. So Baja California Sur is 3. back here. Okay, this is another case that justify the additional processing, because with the merge function, the first thing is the merge function doesn't produce one single polygon. It produces less polygons than the original ones, but still, yeah, because for example, like this one, like the state, it's not just the mainland. It has islands like this. So each one of those islands, they become separate polygon from the mainland, right? So the question would be, why don't you just take that result of the merge and print it out? Yeah, but as I said before, there are polygons that somehow live inside the mainland. I don't understand exactly why, but that's why I need to remove them. The first thing that I did was, okay, let's just take the first polygon, which is always always like the biggest one here. Well, maybe not always, but that's why I modify my code, because I don't want to rely on that assumption. But anyway, so I thought first, okay, just take the first one and then you got the nice shape. Yeah, that's correct, but then you ignore this island, so then I had to go back to my code and do some additional processing. Like, okay, fine, I can't simply take the first one. I need to pick some additional ones. Now the question is, how do you know which additional ones? Because you can pick the island, which is what you expect, or you can pick something inside the mainland which you don't want. Well, that's what the additional processing is about. So for each state, you can specify, okay, how many polygons do you want for that state. If you don't specify that, you just take one, which is the case for most of other states, which just landlocked, right, the mainland. But for things like states with coastlines, like these states, you need to specify some numbers so you can capture the islands. So yeah, the first thing I did is, the idea is simple. You just want to take the two ideas. First is, you just want to take the biggest landmass. So how what is you don't in my code we don't specify the like area, how many kilometers, square kilometers. No, you just specify, okay, I just want to have like the seven biggest polygons in this state. So like this one. So these are the numbers. Then we use a function called this is the key. In order to compare the size of those landmass, I need to use this function, and this function called planar area, and this function is available in a package named topo.json. Simplify planar area, planar ring area. I don't quite understand the difference between these three functions. Maybe I can kind of guess. Spherical, maybe the enclosing sphere. Triangle, like the enclosing triangle area. Ring area, yeah, maybe it's the most precise Yeah, it's the most precise. And of course it takes more time to calculate than this one. Yeah, I use this one. I come in a loop. I go through all the polygons and basically sort them and then cut them to the, let's say, the 7 biggest ones. And then once I get that, I merge them back again as one topo JSON object. So yep, that's it's all about. That's the processing that we have for to obtain this state border, which is now, you see, it's quite detailed. It hasn't gone through the simplification process, so you can see like these smooth lines, and it captures the islands. Yeah, why is it displaced? Well, it's because of the input. Maybe the GeoJSONs that we receive is not that accurate, maybe, or I don't know which one is not accurate here, whether the GeoJSON or the Google Map. So I don't know. Oh, I forgot this one. Oh, see, I forgot to capture Isla San Francisco. But first, I need to check if does it really matter. In this case, because we're monitoring an election, I need to know if there's any voting district in that island. So the way I check that is let's just draw the original data. Sections, what was sections 14, right? What is the name of the island? Isla San Fran. Oh, no, it's a sections 3, Baja California Sur. Sections 3, there you go. And where is it? It's below Isla San Jose, I guess. Below Isla San Jose. Yeah, right. Where is it? Oh yeah, so it does matter. there's a voting district. In fact, this small island also has a voting district. Interesting. Who lives in that island? Why don't they just cross to this island to cast their vote? So yeah, so what do we do here? Well, give me a second. What else am I missing? Isla Partida. Also, I'm missing Isla Partida. Yeah. So simple. I just have to increase this. Maybe so. I'm missing 2 islands, right? So maybe if I increase this to 13, is there any more island missing? 13. Oh, there's another island here below the Parque Isla Montserrat. Does it matter? Yes, it does matter. So one more, 14. Let's just put 15 and rerun the script. What? No. Rerun the script. Oh, I should have just run the script for one file. Now it's running through all the states. No, just 1 minute. Bear with me. Thank you. Yeah, lots of displacement here. It's not. This is the input that we got. You see, one island. It's displaced by one island. uh, okay, is it done? Yes, it's done. Again, bulk to topo geo. Okay, we got it. And let's refresh this thing, and Hidalgo border sections 3. Boom. Yeah, I think we got those islands covered now. Okay, we got the Montserrat covered. Oh, we still miss the Santa Cruz. So yeah, so you got the idea. You just, okay, you look back into the map, compare that with the input, and then just increase, or increase the number here. Alright, that's all. So that's one of the things we're doing with the map, and there's some other things like I'll have to do the same for the municipality to to get the border of its municipality, because for our input, as you see, is broken down into section electoral, voting district. So yeah, I need to merge them. The same technique as the one applied for the state. What else? Yeah, and import them to, let's say, MongoDB or PostgreSQL, so we can exploit the geospatial features that those databases have, and with that we can have a efficient UX for the election, because you know the idea, if you don't need to load the entire the JSONs for the entire country, you just have to load the JSON for maybe the municipality that falls within the bounding box, and yeah, and then for things like, okay, so do a query on this table to find which the names of those municipality, or the codes of those voting districts inside the bounding box of the map, so we can fine-tune our queries only to load election data for those voting districts. So these kind of things that we need to do in order to make our dashboard more responsive. Okay, that's all, guys. See ya later. Bye.